Greetings everybody, I'm Zoe. Welcome back to the physics engine thing that we are working on. Last time we left off, I was in the middle of trying to make sure that, not this, but this was working. Because I was having some issues with some pointers and stuff, and I was having some truly bizarre bugs. I spent a very long time trying to fix it. Not that I ever did figure out exactly what the issue was, but I was having problems with Raylib and stuff, so I spent time in between episodes switching to SDL, which is working very well. Here, let me show you what's going on here. Yep, so we have our two particles and yada yada. So, also don't worry about all these messages. In the process of trying to debug, I figured that the C compiler I'm using totally has like a memory leak checker thing built in. Oh shit, super quickly, I'm sure y'all want to see my face, so I made sure to configure my webcam properly. Let me turn that on real quick. Yeah, there we go. Okay, so I was just working on PF generator registry remove, but in between episodes I managed to get registry add working perfectly, and I'm sure that this sort of stuff is kind of interesting to some people who aren't super familiar with C. But basically, in C, you don't really have like a standard vector or a dynamic array. So you kind of have to do it from scratch. And this is really simple. So whenever you have an array, it's just a sequential quantity of data, right? A sequence of data that's however many items long. So for us, generators is meant to be an array of particle force generators. So what happens is we allocate space for like 1, and then every time we want to add more elements to that array, we need to resize that element. So what we're doing here is we're calling a function called realloc, which attempts to take a pointer and a new size and find new space in memory to put that, and then it moves it around and all of that. And that's kind of how arrays work. The whole like bracket notation, like if you go like array and then I, these brackets is actually short for basically that. Because at the end of the day, pointers are just integers, and you can add and subtract from them as if they were normal integers, and that's kind of how you access the amounts. And with like pointers and stuff, I think that there's some compiler magic in the background where if you plus 1, it works out how many bytes that is based off of the type of the pointer. So if we did like generators plus 1, it would really be plus 1ing the size of whatever a particle force generator is, because that's the type of the pointer. The actual data is an integer, but the type of the pointer, being a particle force generator, lets the compiler know kind of like how to work with it, basically. So anyway, this is really simple. How we're going to be removing items is a little bit more tricky. So this code right here seems to be working, and I'm going to lay out the issue in just a moment. So what we're doing here is we're opening up a for loop, and basically we're looking for a match between the particle that we've given in the thing and in the function parameters. We are looking to match that particle with the particle within register. See, here's that bracket notation again, working exactly how you would expect an array to. And so here we're just checking if they match, because since they're all pointers, we're checking if that position in memory is the same as the other, and so then it would be the same pointer. If that's true, what we're doing is, so there is a couple of functions. There is memcopy and there's memmove, which do very similar things. They both take a chunk of memory and copy it or move it to the given destination. So this copies from here to here. But the difference between memcopy and memmove is that with memmove, if the memory blocks that you are trying to move overlap, which I'm doing intentionally here, if they overlap, memmove will overwrite those bytes, but with memcopy, the behavior is undefined and it'll throw an error. So this all looks pretty great. So we are taking the position of the particle, and we're taking that position plus 1. So we're basically taking all the memory above our point, and we're shifting it down 1, basically. And so here we're like, okay, so we want to, this is the number of items that we want to get. So we take the registry count minus whatever I is, times size of, yada yada, and then we minus count, and then we reallocate the whole thing so that we're staying nice and even inside of our amount of data that we want, basically. Because if we didn't reallocate, then we would have like a duplicate particle way at the top. And since count is less, since count has been changed, honestly, that would probably be fine, but I don't want to have that extra particle force generator hanging out at the end there. So that's why I'm reallocating here. Yeah, but there's an issue here. Let's head back over to main. I uncommented this because I wanted the thing to compile for the video. But if we run the thing, we get all these sorts of errors. Lots of very fancy errors from GCC over here. Basically, we see here heap buffer overflow at these addresses. And we can see it will give us like the stack callback for what happened, and we see that it happened at line 102 incclone.h. It's all, by the way, this is called cclone because the name of the physics engine in the book I'm following is called Cyclone, but I'm writing it in cclone, I don't know. This is line 102, and it's kind of counting this whole thing. I opened up the function into this kind of multi-line thing going on here just so it's a little easier to read. So it's not happy about this. It's saying that there's a buffer overflow happening at that function. And we can kind of see, I don't fully understand this graph. I believe these are, these lines here is how much space we have allocated for particle force generators. And then this is padding added because we're compiling in like debug mode. And what we can see here is that this guy right here, I believe that is not good, considering it's not the same as over here. Not sure what this is. But basically, we had an overflow happening. And right here, we must have accessed memory that we don't have allocated because heap left red zone, I'm going to assume just means unallocated memory. Kajin! Hello.
Live B reaction.
Yeah, I wanted to have my webcam on so people can see my reactions. Anywho, so this is all this to say we are accessing memory that we shouldn't be. And normally that would just throw a seg fault, but I got the special compiler flag on, so it's giving us more information. I know what's happening here. So let's say, for example, we add a, here, I have this thing called trash particle that's just there because it's trash, also typing. So I added it, and it's just going to get removed straight away. So this particle is hanging out at the very end of the array. So if it's hanging out at the array, if we plus 1 to it, then that means that we are accessing memory past the array. So here is the plan. Here is the plan. I actually don't have a plan. That's I'm trying to come up with stuff on the fly. What if, let's see. We could run a check and see if I is equal to or less than count, no, or greater than count, then we would probably do a modified version of this where we don't add 1 to it. But that sounds a little wonky, but that could be a temporary fix until I come up with something better. So here's my plan. If registry count is greater than I, no, that wouldn't make a lot of sense. If it's at the end, then I would actually be 1 less than count. Also, I misspelled registry. If registry count is greater than I, Not greater than I. That's not what I want. Let's try and break this down in my head. If registry count is greater than I, here, let's go registry count minus 1, because arrays start counting at 0, but our register count starts counting at 1. So minus 1 is greater than I. So let's say we're at the very end of the array. Our array would be 3 elements long at this point. So I would be 3, assuming, you know, in the case that has been laid out in main, we are trying to remove an element at the very end of the array. So that would mean that register count would be 3, would be minus 1. Sorry, would be 3 minus 1 is 2. So this would be 2, and I would be 2. Maybe should be greater than or equal to. Okay, so let's come up with another situation. Let's say the pointer we still want to remove is still at 3, but say our array is 5 elements long. So array count with minus 1 would be 4, and I would be 3. That would not be greater than, and then we would still have a space. Okay, I think this would work. I think this would work. I'm gonna tab all this forward. I wonder if there's like a fancy Vim thing where you can do to like automatically shift a bunch of lines forward one tab. I'm sure you can, but I'm not gonna spend time doing that. So, did I copy like an empty thing again? I'm not sure what the hell I'm doing wrong. Shift V, yank. Oh, I was hitting U. I don't know what that would do. Well, I know that U means undo, but whatever. Cool. So now what we're gonna do is actually we don't want to move anything. We want to move. Wait. Okay. So this actually we might be able to straight up reallocate like right away. Actually, yeah. Okay. Yeah, so in the instance where the element that we're trying to remove is at the very end of the array, we would simply reallocate the whole thing, and it would just simply shave off whatever is at the end. So you count minus, times size of, okay, that might be perfect. And then I'm going to copy these and put them down here again. And then return on both of these. That might work. Let's see if it works. That is a much nicer issue here. I misspelled something again. Cool. Did I do that anywhere else? Also, why did that hit? This code block shouldn't have been... Actually, wait, no, it's compiling. I probably fucking saw it. Did I do the same thing there? 110. Doi. What the hell? Amic. Okay, as far as I know, that worked. Detected leaks. These look like about the same issues that I was having beforehand. I think these are just like kind of weird background stuff in SDL. But that might be working actually. I guess the only thing left to do now is to crack open the book and like implement what this particle force thing is supposed to be. Oh, actually, super quick. There's one more thing I want to do. I'm gonna registry clear. Free the pointer. Set it to null. Set count to 0. That might be fine. Actually. And I'm also gonna add a pf generator registry destroy. Registry. What we're gonna do, we're gonna free. This isn't really gonna mess with anything. This is just gonna free generators. Cool. I think that should be it, because ideally we wouldn't be doing anything else with registry generators. At this point, we're just freeing it, and we're not touching it. Alright, let's just do that. Let's make sure we actually take care of that. I always forget what the hell I named this thing. PF generator registry. PF generator registry. Destroy. Registry. See if it was happy with that. It was. Oh, also, something up with my system. You're gonna notice there's a bit of a pause, like pause start. This should be instant, but I believe there's some issue with my graphics drivers on my computer where it's taking a little bit to load in the graphics driver for SDL. Truly do not know why that is. Okay, so I think we're good to go to actually implement the functionality for this. So the implementation is firework bullshit. We don't care about this. Where it's principal math stuff. Force generators, yeah, so we have mechanism for applying multiple forces to an object. I'm not gonna read this out, I'm just gonna skim this. Wait, actually, I just totally realized something. We need to make sure that trying to remove from the middle of an array also works. So let's try and just quickly remove. Let's try and remove test particle 2, just temporarily. Registry, remove registry, position at particle, yeah, let's do 1. Yeah, okay, cool, wow, I really love when, like, I do a thing and it just works. Awesome. Back to reading this. Alright, so here's a quick thing that we need to implement. It's going to be, it's going to have vaguely similar functionality to what we got going on here, but I need to be able to adjust the force of a particle easily. So what we're going to do is we're going to do something very similar like what we did above, and we're just going to go pf generator registry add force, because that's what I have particle add force up here, and I want things to be consistent. So we're going to go pf generator registry, and then we're going to get a particle, and we're going to get a vector 2 force. Now it's not a pointer because it doesn't need to be. Not everything has to be pointers, despite what many people will say. For int I equals 0, registry count I plus. Should really figure out how to add code snippets for like for loops and stuff. If registry briefly forgot how to type I dot particle. Then what we're going to do is here, let's do particle target equals. So I don't want to have to type in registry arrow generators I dot particle over and over again. So we're just going to hold onto it in this little variable to make things easier. So now we can be like target velocity equals. Actually, you know what? I take it back. Let's just actually, that's not true. We need to actually wait, no. Hold up. We need to update force of a particle. hold up. Okay, particle force generator. Update force. Just give me what the hell the registration, add, remove, clear. Update forces. Just show me the code for update forces. Update forces. Yeah. Oh, what the hell is this? What the hell is this iterator bullshit? How is this easier? Oh, I guess that's how you iterate standard vectors in C. Update force. Oh, okay. So it's just calling. So it's just calling this up here. Okay, no, never mind. So what we're gonna do is particle force accumulation dot x plus equals force dot x, and then we're gonna copy that and swap everything else out with y. Yeah, cool. This book broke a lot of its little like little things like this into like functions. Like it has a lot of like add vector, multiply vector, yada yada, but like honestly I just find it simpler to just do it manually, honestly. I think it reads I think it reads a little bit better too, and I don't like having all these functions cluttering up my like things, especially for when I'm trying to learn something. I don't really want it cluttering up. Cool. I think that should be working now. Yeah, so right here, gravity force generator. We can replace our previous implementation of gravity by a force generator. Okay, so what it's doing here, class particle gravity. It's gravity. Particle gravity. It's a function. Is that a function? I don't know what this is doing. Natural void, update force. Particle gravity, update force. What kind of weird bullshit is this? Okay, so this is just... Okay, so this... Okay, so what we have here... So we have a class, and obviously we're not using classes, but this is a class that just takes in a pointer and then adds gravity to it. If the particle's mass is 0 or infinite, it'll do nothing. Okay, alright. Sure. Sure. We don't have... This could easily just all be a function. Yeah, so let's go add force. You just take in a particle and a delta. So here's the plan. I'm going to put this... I don't know where to put this. Okay. You stick this somewhere more... Stick this somewhere where it makes more sense. Because I wouldn't really put a... I wouldn't really put like a gravity thing in my fucking physics header thing. I wouldn't do that here, but I don't want to make a whole new file right now. So yeah, that's just temporary. We're gonna go particle in, and it has its own gravity. Oh, this is like a singleton thing. I'll just replace that with a hash define. Then we're gonna go float delta. Yeah, let's just freaking hash define gravity is just gonna be, what do I want gravity to be? What do I want gravity to be? This book definitely has something as gravity. I'm not sure where gravity is. Force generators, where do they want gravity? Let's see. It's gonna be excuse me. Create variables, rules, pen rules. Cause I'm pretty sure they didn't set gravity to be like what it is on planet Earth, but to something else. Particles and physics. I'll find it. They straight up are not giving me what the hell they want gravity to be. It's literally not there. Alright, well, I'm gonna make it 10 meters per second. Screw it. Or whatever the equivalent of a meter. I'm pretty sure like 1 pixel is 1 meter in this, kind of, which doesn't make a lot of sense. Let's just set it to 10 right now. Yeah, so add gravity is gonna be done here. I just passed it, didn't I? Yeah, it's right here. Let's use my fancy that. And here's the plan. So I'm trying to think. Inverse gravity, if it's 0, inverse mass, sorry. I'm pretty sure 0 is like infinite mass and 1 is like no mass. So hold up. Inverse mass. Just like setting inverse mass to 0, infinite mass. Okay, cool. Yeah. So if inverse mass, I have no idea why in the book they have like a value that's like is finite inside of its particle class, but like why on earth would you do that when you can just like use inverse mass? If inverse mass is equal to 0, then we're gonna do nothing. Else, we're gonna pick in in force accumulation. Actually, no, isn't this meant to be going through the? Isn't this meant to be going through the? No, no. Actually, no. I want this to be y, because it's gravity. In force accumulation dot y plus equals gravity. Cool. All right. So I believe all these guys have a mass of like 0. I think. No, that has these both have a mass of 2 kilograms, or whatever it is converted into digital pixels and stuff. So let's see. Now I say, where does it want me to put that? Where does it want me to add my gravity? Where does it want me to do that? So I don't know where it wants me to put it. So it's not telling me where, and it's mysteriously not using the particle force generator registry that I've been spending so long working on. So I'm just going to throw it here. I'm just going to throw it there. I should make delta just like a float. Oh, I can talk about delta. Y'all want to learn how to calculate a delta? So delta is the time between frames. In math and stuff, it's the time between 2 points of measurement. Like, oh, you measure at second 1, and then you measure again at second 2, the delta would be 1 second. If you measure at second 1 and at second 3, the delta would be 2 seconds. So what we do here is we take a double is like a float, but with more precision. So we get whatever time it is currently. So this is after we've initialized and everything. And so this is going to get however many milliseconds after the program has started. And you get milliseconds since the program started by querying the performance counter, which is like an operating system thing, and divide it by SDL get performance frequency. I'm not sure what frequency is. So this is how you get the number of milliseconds since the program has started, and then you get the whatever that was the previous frame, I guess, or iteration of the loop. So obviously at the very start of the application, this would be 0, and frames is frames per second, so this is the number of milliseconds per frame. 1,000 milliseconds in a second, 60 frames per second this is like 0.16 milliseconds, or like 16 milliseconds, something like that. This doesn't need to be that, actually. This just needs to be that. And then to actually calculate that, we change the last time to the current time, update the now time, and then subtract now time from last time, and that is delta. And you multiply any kind of position adding thing, like when you're adding your gravity or your movement or what have you. If you multiply it by delta, then your movement will be frame rate dependent. And any number you put into that movement code, it will be pixels per second instead of pixels per frame. Pretty cool stuff. So, back to what I was doing. So we're doing particle add gravity. And, I was about to just go up and change delta to a float so that we don't have to cast it to a float every damn time that I need to use delta, because that is annoying. And we don't need that kind of precision, in all honesty. So delta equals, you know what? Fuck it. Let's make it all floats. Can I do sub-word? No, I can't. Cool. Alright, so that should be working now. That's how delta works. We can get rid of these now. Doop, doop, doop. Yeah, oh, hold up. That needs to be test particle 2. And this should be adding gravity, so now all of our particles should be falling. Error expression, I made a mistake. Forgot a semicolon. Yeah, look at them go, wow. That's fun. Alright, so next up, the other thing it recommends we do is a drag force generator, which is calculated with whatever this bullshit is. So, let's see, it's kind of, so particle drag, that's the class, inherits from particle force generator, because object-oriented programming is great, I guess. Drag coefficient, square drag coefficient, creates the generator with the given coefficients. Drag. Okay. To the force, get velocity. Real drag coefficient. Force dot magnitude, that's a math thing. I need to reference magnitude equals K1 drag coefficient plus K2. Where is K1 and K2 defined? I mean, okay, obviously they're defined up here, but generator with the given. Okay, so we're going to create a new one of those, or we could hash define it like we did gravity. It better define it. It better tell me what numbers I should put in for that. It doesn't. It totally doesn't. Squared. The hell am I supposed to put in for freaking? Okay, let's see if I can. Hold up. Physics, cyclone, source. Yeah, here we go. Let's see if I can sleuth through this code and figure out what they want me to put into it. Is there demos? It's gotta be in here. It literally doesn't say. Alright, well, we're going to just come in here and add it. Implement it how it wants, and I'm going to assume it's going to tell me when to actually use it. So, we're just gonna... Not that. Particle, add, drag, particle, in, delta. In this book, it calls delta duration, which is weird as hell. Force. Good velocity force. That's so dumb. Why would you have a Why would you have a function to give velocity when you can just go vector2 force equals n drag. Sorry. Bell. That doesn't make any sense. Calculate total. Alright, so float drag ho f equals force.magnitude. Okay, so I gotta you know what, can I just calculate vector magnitude? Because I'm pretty sure it's really simple. The length of a vector. Yeah, so that's just like one plus the other, right? Tell me how to calculate this. Square root of what the hell? I guess these are mathematical vectors and not like direction x, y. So if we just do, okay, so it's the square root of x1. Okay, all right, okay, sure, okay, yeah. Unless I did add a magnitude in. Oh, I did. Yeah, it's right there. Let's just yank it and copy it, because who cares? Oh, that's the only one. Yank, and then we're going down. Why? I don't... Fine, whatever. So, wait, how am I going to get the magnitude of force? Did I miss something? Where's force? Where is force defined? Force dot magnitude. Alright, we're talking. Okay, no, so it's force dot magnitude. Okay, alright. Okay, yep, I got it. I'm going to shut up and just code this. Alright, this should be all implemented as far as I know. But like I said, we can't see if it's implemented because it hasn't told me what K1 and K2 is. You know, maybe I should just read this. Where K1 and K2 are two constraints that characterize how strong the drag force is. They're usually called the drag coefficients. You know, I really should just read more, honestly. They depend on both the object and the type of drag being simulated. The formula looks complex, but it's simple as practice, yada yada. Opposite, this is the negative, P is the normalized, drag has K2 value. Go faster at higher speeds. In this case with the aerodynamic drag, it's less speed, it's no drag. Okay. So, okay, well, I think I get it. Also, why did I call this particle update? No, I almost got confused for a moment. No, it's right here. Particle add drag. Okay, so let's just run over here and we're gonna go particle add drag. That's particle delta. You know what? I think I'm starting to realize why. You know, last episode I mentioned how I didn't really understand the point of having a particle force generator registry, but I'm starting to get it. A particle force generator registry, I imagined, would solve having to do all of this. Because as you add more and more, it's going to do this. So, I think I'm going to have to figure out... some different way. Since it has like classes and stuff, right? And in the registry, you can just throw in a function that'll calculate the, force, but you can't really do that in C. So, I don't know. I might have to come up with my own completely independent solution from having a registry. Like, just having, like, a special kind of particle point, and then inside of it, I'll have, like, its own... Like, maybe inside of it, I'll just have, like, bools that has drag, has gravity, etc. And then store them all in an array, and then just do the update gravity, or just throw it all inside of particle update, honestly. Also, I just realized add gravity and drag should happen before. That would make more sense. So K1 and K2 are currently nothing, so we shouldn't see anything happen. Add force. What are you talking about? Particle, add, drag. No, that's a real function. I think yep, that's what it's complaining about. Yep, that would make sense. Sorry, where's that? C clone 90. Oh, right. It's not a pointer, I'm just gonna... This is nothing. This is nothing. You happy now? L2. Did I make this... Alright, all the dumb bugs out of the way. I truly do not know if that did anything. Here, let's set gravity to 0 real quick. So default, start doing hash defines. Gotta rebuild everything from scratch. Okay, it's going ahead. You know, maybe I should just change these to constants, so I don't have to recalculate every single time. Yeah. Why not? There's not really any, like, difference in terms of usability. I mean, there's a little bit, but not any that's gonna affect me. Let's just make those constants. That should totally still work. Nice, so now we won't have to recompile my entire program every time I change a hash define. So, gravity. So let's change these to frickin' 1. So, okay, I didn't see much of a difference. Doesn't seem much slower. I'm gonna read more. Well, I read more and it continued not to describe anything, so I'm simply not gonna worry about it. Cool. Hold on. What happened to my gravity? What happened to my gravity? Duh. Silly mistakes. Silly mistakes. I also forgot to add semicolons. Okay. Yep, there's our gravity working again. Alright. Well, hells to the yeah. So we did get a lot of stuff done. We got our particle force generator registry taken care of. So far this is all really kind of like loose and messy because I'm just trying to follow this book. And so I'm just kind of doing what it says. This is all kind of, once I learn all this stuff, I want to do my own implementation, which is all the way that I would do things. But yeah, so that's probably where I'm gonna leave it for this time. I hope this video was interesting. I hope that my commentary was a little bit better. I'm gonna continue practicing. Keep on doing this. Hopefully the next episode will be kind of soon-ish. Since I have all the weird bugs that I was dealing with taken care of. Springs don't sound super interesting, so maybe I'll just do some of this in between episodes, or maybe I'll figure out like a better way of doing this. Excuse me, this particle force generator registry thing. Excuse me. Maybe I'll figure out a better way of doing this, where it'll actually work. But yeah, that should be it. Yeah. So, thank you all so much for watching, and I'll see you in the next one. Doodles.